All right, so let's give this, yeah. Cool, hello. This is the second installment of our adventure into SQLite. Last time we spent a fair bit of time exploring sort of header files. So let's make their way to this project. Let's see, it was SQLite 3H. It's this one, what we explored. And I got a lot of really cool feedback on the last video. So it was some things like, what is autoconf, which kind of ties into an explanation about make. I recognize that not everybody has used C in the past or has used it very lightly and doesn't really understand the ecosystem of how C projects are generally built. So I felt it might be good to maybe spend 5 or 10 minutes to talk about autoconf, maybe talk about which kind of, if you're going to talk about autoconf, you kind of have to talk about make. And the other things I was going to kind of focus on that I had as goals today, which is why I'm looking down, is I really wanted to get things building right so that we can actually start tweaking it. Whether we do that through tests or whether we do that through just a script that reruns it over and over again, we'll kind of make it up as we go, but that's a bit of the idea for today. And we may also investigate some sections without looking specifically at the internals, like, so this specific, sorry, this is gonna annoy the hell out of me if I don't fix this right now. Oh no. Okay, figure it out. Instead of focusing on the internals with this giant amalgam file, I felt it might be best if we look specifically at the source directory and each individual module. Now there's a lot going on there, and what we talked about last time, let's go up. I got some feedback that this was a bit too small, so let's see if I can actually increase. I don't know my keyboard shortcut for this. What is this? It's Shift plus, but what is that here? It's a Control Shift plus? Yeah, Control Shift plus. So I'm going to kind of increase the zoom a bit by 133. And the main focus here was kind of this image. And we looked over the header file and we said, oh, okay, well, sort of see the individual pieces and how they work. And it was nice because we could infer specific ways the system was being instrumented or internals, right? Like we found out that SQLite is a dynamically typed virtual machine, right? That's what the virtual machine does. It confers on typing at runtime, but that it's strongly typed like Python. Right, Python is a dynamically typed language, but it is strongly typed, and what strongly typed means that we said last time is that there's no implicit conversions going on, right? You're not going to have integer promotion or anything. Now, you might think that this is a bit of an odd claim because what we call the host language to the virtual machine is C, and C is a weakly typed language, right? It does implicit conversions. But there are ways around that, right? If you're pretty careful, and we might actually see bits and pieces of that here. So, what is autoconf? Maybe I should go open this up. Autoconf, oh no, am I gonna have to do that for every single thing? Oh, that's crazy. I'm sorry, I'm not going to do that for every single tab. See, once upon a time, right? Let me see if I can get a terminal open. Let's go to a temp directory. Okay. This temp directory is going to be just a simple C project. So, hello.c. Let's call this main.c. All right. Main.c is going to import some stuff. Include io.h int main and then return 0. I'll pretend everything is fine. I'll make this a bit more clear. And we're just gonna start with like the simplest thing, right? Right. Okay. You have a compiler, and a compiler lets you compile source code into an executable library, right? A library, a binary. It produces some artifact. GCC for the GNU compiler collection is 1. There's also Clang. Let's see if I have Clang on this machine. It'd be good if I did. This is, again, I'll mention that I mentioned in the last video, this is a relatively fresh machine. I do have LLVM on most other of my machines, but I'm not going to bother installing that right now. The invocation of building this is to say main.c, and you'll see that if we don't put any arguments, we get this result called a.out. That's just a historical thing, right? And if we run a.out, we get our program. Cool. Okay. Now, maybe we don't want to call it main.out. We want to say main.out is actually hello there. Cool. Now we've named it. Maybe we want to put that under a distribution directory. Right. So now every time we run this, right? We're going to have to say dist. Cool. And let's rem. This is all well and good, but we can't just keep doing this direct invocation over and over and over again, right? So what we want to do is we don't want to be the machine, and we want to automate. Okay? So maybe we write a script. Okay? And let's do that right now as sort of an exercise. So build. The convention is that a convention that I subscribe to is that executable shell scripts don't end in .sh, and sourceable shell scripts end in .sh. So we don't put a .sh on this. Maybe we put this in a bin directory, you know, because we're going to have scripts to build this project. That's fine. So let's look at the pieces of what this is doing, right? Sorry. It's also We'll do that later. That's a nitpick thing. You'll see that we are now directly calling this, and that there is input and there is output, right? This is like a function almost, right? And so we take GCC and we feed it inputs, and GCC does this thing where it'll produce object files, and it will do linking, it'll do all this other stuff through this whole process. And we'll talk about compilers another day. In fact, we'll have to talk about compilation a little bit when we talk about SQLite, because it has a compilation step where it takes the source code of the SQL statements, transforms that into bytecode, that's the compilation step. And that bytecode then is fed into a virtual machine, which is kind of like an interpreter, okay? A live running interpreter or evaluation, right? So this is all well and good, and this works, right? We can say build. And you'll notice, because I had this X for tracing flag on shell, we could see the results. And that's just kind of a handy thing. Okay. That's all well and good. What if, right, I start getting a lot of source files? Let's just say I get a lot. I get all these, right? I've got tests in here. I've got, you know, direct source files. I've got everything, including header files. So a good example of this is actually to say, maybe introduce a new one, right? So let's, let's create a new one that is the hello module, right? So we're gonna say hello. And we're also gonna, so let's do hello.h, right? A standard, what is it? It's if not defined, if undefined. I'm trying to remember this style. Let's go look at a header file here, because I'm certain a header file in this will have it. Just want something SQLite. Let's go. Yeah, here you go. This guy, right? So it's this. What is the point of this? This is what we call a header guard. A header guard is, it's used to, maybe I can best explain it here, right? If this is not defined during compilation, then define it, and then do the rest of all this stuff. And at the very end, and if, right? In fact, this end if, I think, pairs with something else, actually. Yeah, you'll see this pairs with that. I'm hitting the %sign in Vim, which you go between matching blocks. It doesn't always work, but it does work with defined statements. So you'll see this if not defined FTS5 header, then define it and do all this stuff. And the point of that, just as a quick digression, is to make sure that a header file is sourced only once. Okay? So we do that, and then we say that there's this function, it's a void function, it's called hello there, right? It takes no input, and that's it. Simple. Some people do this, some people don't. This void in the argument position. I won't. Cool. This is a header file. Header files contain forward declarations of types, and they contain forward declarations of functions. A forward declaration is where you say the shape of a signature, right? A signature is all the types and stuff related to a function plus the function name. And then what you do is with that, people sort of have this interface to a module. Okay? I am going to just call these modules to keep it simple. Now, we say include. And when it's a local file, you use quote marks. And when it's like a statically shared library, I believe you use the classic, you know, or dynamically shared library or statically embedded library, etc. I think it uses the brackets. I'm not 100% sure. But now we're going to define the shape of this hello there function. Oops. It takes no arguments, opening, close brackets, and whoops, main, right? Oops. Take this guy, slap him in here, and that is our function, right? And now we're going to say include hello.h, and we're going to just say hello there. Oops. Getting used to this keyboard is crazy. Right? Just squish it a bit. Same with this guy. Implicit declaration of printf, so that means we need to do this guy again. Sorry. There. Cool. Now what are we going to do? Let's try building. There's an error in function main. So there's an undefined reference to hello there. But we included this, you know, hello statement, import, include. That's not enough. Ooh, sorry. All right, something has happened. I will cheat now to get us back on track. There we go. So this isn't enough, right? We need to now say hello.h, because it needs to know about the header file, and we need to know about hello.c. Right. Let's build. Okay. That seems to have worked. Oops. And we're still good, right? If we viciously remove this directory and we build, you'll notice that fails. So now we need to do this. And to make sure that always succeeds, we'll do -p. Okay. Okay, now we've got a second step in there. So you'll start to see that even for a tiny little toy thing, we're having to do a bunch of stuff to get this all rolling, right? Enter make, right? Make is a program that has two basic ideas. You have targets, right? Let's see, my bad. I am determined to get the hang of doing this. Okay, so it's been a little while, but I need to remember how to get just object files, because that's all I want to produce. Compile only, do not assemble or link. Compile and assemble, but do not link. Yeah, so let me just check real quick. Hello.h, hello.c. Right. Let me cheat. Only produce object files GCC. CS11, perfect. We're in this part of the internet. What is it? Yeah, here we go, C. That's what I want. Right, so going back, GCC-C, hello.h, hello.c. And if you look, you'll see that we produced this file, hello.o. Right. GCC-C, hello.h, hello.c. And make has things where like it has built-in variables that will refer to all the dependencies. Right, so we could just use that here instead of these. And this is what's called a target or a rule. And this is the steps of the rule, right? So GCC-C is what will happen when this is invoked. So we can blow away hello.h.law. And we can blow away hello.o, right? And then we can say make hello.o. And boom. It produced the GCHkin, it produces the .o. So, what's next? Now what we're going to do is build our main program. We're going to call this, what did we call it before? Hello there. Right. This is going to require hello.o. It's also going to require main.c. And it's going to compile, right? Hello.o, main.c. And it's going to output it to hello there. Right. Now, this directory is what we would call a prefix, or a local prefix. It is the prefix in front of the binary or the target. There's also a prefix that's important when make is used to install things. So very common targets are all, install, which requires all to happen, and then maybe it copies just hello there to, you know, some prefix bin. Right. There is also quite commonly a clean target. And clean is generally marked as a phony target. So make phony. A phony target always reruns. Alright, so I'm just gonna copy that, go back down. And what this is gonna do is it's gonna rem everything. No, that's not what we want. We want just hello. Okay. That's one option. Right. So let's make. When you run make, you're implicitly running make all. So something's blown up here. Ah, because it's trying to run this. Sorry. So many sorries. Trying to get used to this keyboard. So I have a Filco at work, and I have an Ergodox here, and it's a bit of a mind warp, especially since I've still been changing key bindings and stuff on the Ergodox. So cool. How long did that take? That took a while, didn't it? That took longer than the 5 or 10 minutes I think I was going to take to explain even just make. But make is a bit of a beast. It's a build tool, and it'd be really cool to rip the lid off of, you know, the magic of build tools. There are some that are quite modern and worth sort of investigating, like Bazel. There's tons of ones from a paper called Build Systems a la carte, which are worth looking into. So this has sort of a walkthrough of a sort of implicit build system that could work. It has some background on some other ones, how to, it categorizes particular build systems. It's a really cool read. It writes out in Haskell this perspective thing, and it's actually these guys are two really big figures in the Haskell community, so that's pretty cool. This guy in particular, who was kind of the father of Haskell at this stage, one of the fathers. It was a committee-based language, but he still does research for Microsoft, and this is a really cool paper. There are things out there like the Journal of Open Source Architecture. Where is this book? It is this one, the Architecture of Open Source Applications, aosabook.org. There's a couple of different ones of these, but this is really cool because they have people either as maintainers as part of the project, or even the original people, right? Like here's Chris Latner talking about LLVM. Like that's pretty neat. They have people talking about, provisioning tools like Puppet, PyPy, so packaging, Matplotlib, FreeRTOS, right? FreeRTOS, GDB even. This one's pretty cool. It's Ninja. This is sort of an extension on top of Make. And this is a worthwhile read that I'll probably leave in the comments, the description, for people to have a gander at. The cool thing about all of these different build engines is that they're optimizing for different stuff. Ninja in particular is quite focused on speed, so is Bazel, which is another sort of kind of high-powered, maybe some would even say somewhat complicated build tool. Okay, so we've sort of given a very tiny application. We had to write a make file. Now that we have that make file, we can blow away that build script. Cool. But nonetheless, this is tricky. When every single time we start moving things around, we have to change the make file. Every single time that we add a new dependency, we might have to point at different places. And then the moment that we start dealing with external dependencies and we start dealing with things like, does the architecture actually support SIMD? And does that mean that you can build this project? Right? Maybe it looks for particular SIMD intrinsics, right? A SIMD intrinsic is special instructions for SIMD, and some chipsets don't support particular intrinsics while others do. And maybe you need to start kicking in a step that says, hey, does this actually work here? You could easily, put your hands up in a project and say this is all on the shoulders of people coming to build the project. But that's not conducive towards contribution, is it? If you put your hands up and you say, it's really so-and-so's responsibility to figure out, how they're going to get this thing to build, it is a bit of a cop-out. And thus enters autoconf. Autoconf for auto configuration is this idea that you write these files that will perform, sort of checks and expansion and stuff. The gist behind autoconf, right? So let's go look at configure. You will see in this configure file, and you will see configure across many different C projects, that it is generated by autoconf. Okay? Autoconf is a way for us to get platform sort of independence to keep C building pretty much anywhere as long as configuration happens, respective of people's particular environment. So maybe they want a standard installation directory that's different from somebody else. That's a tiny concern, but something that autoconf could take care of. Maybe they want, some sort of extra features enabled. Autoconf could be set up to configure that, right? The configuration step could have options passed to it, okay? There's also a lot of stuff in configuration that also is about support, that we've said before, right? With the SIMD intrinsics, and it could even be other things. When we ran autoconf, when we ran this configuration step, we sort of saw all of this output. And usually you only have to do this, you don't have to do this fairly often, unless, you know, the autoconf files change or whatever. The sort of song and dance that we talked about last time was this. If you have a C project and you want to put that someplace on your system, then that's one way to do it, right? So let's go makefile. We want to look at the autoconf one. Let's go install : here we are, install. And you'll see that it installs SQLite, right? And it runs this install command, destination directory, bind directory, so bin directory, binary. LT install SQLite to destination directory, so it moves this whole directory over, so it installs it, and it does these other ones. And there actually even is a command called install that is like a glorified version of copying, right? The install program copies files, often just compiled into destination locations you choose. If you want to download and install a ready-to-use package on a GNU Linux system, you should instead be using a package manager like yum or apt-get. Somebody had a great tweet about this, which was that your package manager on your operating system is effectively not very different than your package manager in like NPM or, you know, Cargo or whatever, because a lot of package managers, especially for Linux and even BSDs and stuff, wrap up things like libraries and etc. And the point is that many of these distributions for Linux and BSDs are about curation of sets of software that work well together. So Debian is all about that, right? A Debian release is where people have tested a bunch of software in tandem and said all of these software versions should work. You know, they shouldn't have bugs or conflicts between them. It should just be good out of the box. Okay, I recognize that the upper right part of this YouTube video has my head, so some stuff is going to go missing. I'm not 100% sure how I'm going to solve that yet, but we'll pick it up with time. That is autoconf in a nutshell. Autoconf enables us to do certain checks and configurations before running a makefile. And that's because, you know, maybe we just want to generate a makefile that has all the source files and header files in a source directory. Autoconf can do that, right? That's an automation that autoconf can provide us. Maybe we want to, you know, configure particular things for a system, right? Maybe instead of building with GCC, we could build with Clang, right? So that's one example here, right? Instead of GCC-G optimization level 2, we could have had, you know, Clang, right? And in fact, I'm going to be ridiculous and install this in the meantime while we talk. Autoconf is just one part of this puzzle. Makefiles is just one part of this puzzle. C itself has many footguns. The thing about C as a language is that Brian Cantrell had a great description of C, which is that C is effectively portable assembly, right? So people look at it from a performance standpoint about being close to the metal, they'll call it. It doesn't have many different layers of abstraction between it. You can inline assembly if you really want to. And in fact, operating systems do this. Like when you trap into the kernel, that actually invokes a function that runs some inlined assembly that then finds its way into a particular privileged state on the hardware, perhaps, or maybe it simulates it. Okay. Now, what you will find in this investigation is we should be really conscious. Okay, I'm going to close that. I'm going to close this. What you will find is that we may go through like what this image shows, and we may not. We might follow these arrows, and we may not. We might follow this document, and we may not. So don't get your hopes up if you think that it's going to be very simple, tick off the list. I have a feeling that the size of this project and some of the interesting sort of things worth investigating are going to mean that we're going to have to sort of explore in a non-linear fashion, and that's actually really common in a project. Like one video I might give soon, just as like a sort of short treat, is a friend of mine was asking why npm link was having problems with her particular environment. And what I did was I investigated what npm link is doing versus what system calls and what particular process commands, process invocations npm is doing versus the source code that's in Yarn. And that was a very kind of non-linear thing, right? Because I would go down the npm route and I'd find that there were these dependencies, and I'd have to go into those dependencies to sort of go, okay, well, what are they actually doing, and try to keep the scope as limited as possible so that I could, trampoline back up. With that said, we will try to investigate and see if there is let us close this terminal, because we don't need this little temporary project anymore. What we will do is try to see if there's a main file. So I'm just going to go straight into source, and I'm going to try to look for a main program. I do that all the time. There are test files. There's the TCL SQLite, and we should actually install TCL if we have not. Yep. I think it's by the same name too. Doesn't matter. Yeah, TCL should. Cool. And the next thing that we're going to do that I have glossed over, shell.c.in. This is the name of the program. It is set in main, used in int SQLite C declaration main. So let's go look at that one. Static char arg the not. So there's some interesting things here where there's this in file that is possibly being fed around with autoconf. I'm not sure, because I'd be curious why it would be called .in. There might be some scripts that take everything and turn stuff into the amalgam. One goal that I have for today is to get things building. So a really cool tool that I like is called enter. I call it enter. I don't know if it's something else. The way that enter is invoked is you hand it some files, right? So let's say echo shell.c.in. You hand it off to that on stood in, right? And then you say what the command is. The reason why you do this the pipe way is so you're free to write whatever you want, right? So now every single time I'm going to say this, something will run. So that's really handy for us to get into a nice, tight feedback loop. If the feedback loop is taking too long, we might need to split it up into multiple feedback loops. We might have to trim things down or comment stuff out. We'll get to that point. But what I wanted to run was, let's see here. There actually is a really good example in here that says a nice way to sort of get this going. So, Lovely. Let's get this going again. While true, do right. Okay. Yep. So while true, do ls source dot c or h. I'm just gonna say everything that's in there because they all look like .c and .h's. Okay. Enter by default will run the given command on the first invocation. You can actually tell enter, please don't do that. Enter stands for something. It's like the while it's building, let's go find out because it's kind of interesting. The event notify test from here. It doesn't have to be tests. I've used a lot of these tools in the past. I've written my own, which is a great toy project to teach yourself about how editors save files, how different operating systems provide interfaces for watching files on a file system. But really, like, it could be anything. Reload browser Firefox, make test. You can set this up to do a lot of other really cool stuff too, based upon changes that you make to files. And sometimes you can rig it up in sort of a Rube Goldberg kind of way where like you touch a file, right? Which just means that you run the touch command on it and that changes the access time and then that will then cause enter to do something cool for you. So what we've done is now we've set up this sort of feedback loop on the side to build our program. I might, I apologize in advance if things are really hard to see here. I'll try to kind of move stuff down a bit in case it's hard. We did see that the main file was in here, but my plan was not just to make the project, but to also have it do something, right? To run SQLite at the end of it. So if we go back up, first thing we should do is find out where the SQLite 3 binary has been built, right? So here's SQLite. It looks like it's in the home directory. The current working directory, sorry. So yeah, it is here. Cool. Man or SQLite dash help. Sorry. Cool. What we want to know is, can I have it just do something and then close down, right? I just want to script it so that it can like say hello or whatever, right? So that I don't have to keep manually invoking it every single time. Let's actually go back up here and say SQLite 3 run command and switch without invoking storage. Cool. So we can just feed stuff in from standard in, right? Yeah, so we're gonna say SQLite 3. No, I'm gonna have to say SQLite 3 test db, and it will be like So who is telling you about the syntax error? Okay. another way for us to do this. Okay, I think that did it. And then we'll say select star from foo. No such table foo. Okay, create table foo ID primary key. No, it's not that. That's the command again. SQLite 3 help. Is there help? Help. Oh, there is a help command. The help page. I don't need the help page. I need the help command. There we go. Help. Help. Topic. Fossil help topic. So this. That's fossil. Yeah, this is fossil. That's not what I need. Yeah, SQLite source help. SQLite 3 help in shell. Dot help. Yeah, and that actually says enter dot help for usage hints. It was shown to us, so that's a bit, yeah, that was a bit silly. It's here in case you can't see it. Cool, so now we can say, what do I want? Indexes, import. Just want a list, right? Output parameters, progress, prompt, quit, read, recover, save, schema, self-test, show, tables, timeout, timer, tables. Okay. Don't even care. I think I have the wrong idea here. Yeah, so there's this main database. Okay, seems like that should work. There you go. Home RJS repo SQLite test DB. And we have foo. Nothing comes out. Is there a schema thing? Let's go find out. Show schema for SQLite read table. Show. Yeah, schema table name will show the create statement for the table. So we should see roughly what we had. There you go, create foo. Create table foo ID primary key. Cool. So we can say insert into foo values. And we say ID. So echo select star from foo into SQLite 3 test DB. One. Cool. That's going to come really handy later once we start messing with like the engine and stuff, and we want to maybe play or break how values are retrieved. So what's going on here? Something has happened. Nothing to be done for all. Right, so I think I've managed to get myself into a bad place with this tooling. So I might have to kill that one. Yeah, enter make. Kill dash 9. 1, 2, 1, 9. So we actually need to do is kill off that thing. Yep. And we'll go back down here and we will look at our commands. Go up a bit. Where was it? It's this one, right? And instead of this while true, we're just going to say that. How's that? In fact, we can just say foot source, right? Foot source has all these. So star. Cool. I'm not sure if I trust the parsing on that. I mean, let's just try it, right? Let's just see if it will do what I think it will do. There is a way to tell it, sorry, let's start a new terminal here. There is a way to tell enter to, reading this one about R. A process script is created to prevent shell scripts from masking signals. Enter waits for the utility to exit to ensure that resources such as sockets are exposed. Control of the tutty is not transferred the child process. Evaluate the first argument using the interpreter specified by the shell environment variable. My bad. One of these shows the exit code. Ah, yeah. So we can kind of cheat here, and we can say -s. Sorry. Okay. Oh, yeah. Keep winding back there, huh? Cool. So we're going to watch this. And that probably will take a second. Yeah. Yeah, so there's some stuff here like the autoconf things. I'll move this a little bit and make it easier for people to see. each of these has mains, right? Test, db, fuzz, those because those are tests and they need entry points. Entry point is exactly what you think it is, right? If you've never heard that term before, entry point is how you get into the program, and that's generally what is the hook that is run first. Stuff around tool. So tool seems like it would be promising to have maybe the SQLite thing in there, but I think these are utility tools. Like here's lemon, here's a db hash tool, check spacing tool. What else? LT main, huh? Alright. What is LT main? libtool main. Libtool main. Right. Okay. Yeah. Shell.c. Let's go to this one. Do not edit. This file is automatically generated by the script in the canonical SQLite source tree at tool makeshellc.tcl. That script combines source code from, is this the TCL one? From the various constituent source files of SQLite into the single shell.c file used to implement the SQLite command line shell, which is what we want to mess with, right? Most of the code found below comes from the source source shell.c.in file included in the canonical SQLite source tree. That main file contains include lines that specify other files in the canonical source tree that are inserted to generate this complete program source file. The source code from multiple files is combined into the single shell.c source file to help make the command line program easier to compile. To modify this program, get a copy of the canonical SQLite source tree, edit the source shell.c.in and or some other files that are included by source shell.c.in. And then it's telling us to rerun tool make shell c.tcl. Okay. I think it would be good if we go to this guy and look at some weird TCL. Now, this is a pretty short script. 72 lines. It says we need to run it to generate shell.c source file from other constituent parts, and that no other arguments are required. So let's see if we can run it. Right. It looks like TCL sh is in the right place. So where was this? It was make shell permission denied ls make shell sorry. Owned by RJS but not executable. So we could make it executable. We could also just say tcl.sh tool make shell c.tcl. Now, you'll notice that this finished. Took a little while, and we know that it finished now because this thing said return exit code 0. Okay, so that seems to spit out the text. Right. I'm guessing if we look we'll find things, let's go shell c in, make shell c.tcl. The source code for several runtime loadable extensions is inserted below by the tool make shell c.tcl script before processing. That includes work. We need to override some macros to make the included program code work here in the middle of this regular program. So this probably means that we can't just edit this shell.c.in thing. Especially if we go back to where we were looking. Where was that? That was like, that was the shell.c one. Yeah, and it told us that if we wanted to hack on stuff, we need to run make shell c TCL script. So let's see if we can go to make shell c TCL script and see what it's doing. So it has a set thing here called set top directory. It says set out stood out, puts out do not edit. So this is spitting out some stuff. This is specifically what we read. Do not edit this file. Set in. So what we can do is TCL sure, and let's pipe this. Okay, I'm going to have a brain fart right now. There we go. Into less. And yeah, this looks like that file, which probably means that if we can go to part of the make file, whoops. There you go. Shell.c, its target, remember, is made from the TCL should command running top directory tool make shellc.tcl, and it spits it out into this file, shell.c. If we edit shell.c directly, we are not going to get anything, are we? Right? We're just going to get it constantly replaced. Shell source top tool make shell.tcl are required. So make shell.tcl script is required and the shell source is required, right? That is the amalgam of all of these files. Shellc.in, append vfs.c, SHA3.c, fileio.c, completions, SQLR, SQLite3 expert C and its header file, zipfile.c, memtrace C, and test win directory entity or entry or something. So cool. Let's go back to that script. Shell.c.in. Before this video concludes, the one thing I really want to try to get going is at least for like the input of the shell script to be changed. I may be cheeky, and since we have a step here, a feedback loop that's building, it might have, might modify that. We might have a second feedback loop that simply runs the SQLite3 command just to look at the input. And what I want to do is I want to see if running the SQLite3 command we can change just something simple, right? Something really, really simple. Okay, so here in this script, make shell c.tcl, proc emit redundant type defs. This is like a function sort of. I'm really just trying to see if it's including stuff from a whole bunch of other weird places. It's doing some regex stuff, spitting out this thing. It's going across, so this is like a while true, I think. So we'll just keep running until it breaks. Actually, I don't know what the specific keyword is, whether it's break or what. Set lx emit redundant type defs. If there is a thing that says include SQLite, then change that out. If there's a thing that says include test win directory, and change that out. Yeah, puts out line expert iline shell.c.in. Okay, I think we'll just have to experiment. I'm assuming on good faith that the, what was it, shell.c target is being used elsewhere as a, yeah, so the SQLite3 executable requires shell.c. That means shell.c is going to get built every single time we run the SQLite3 rule, and the SQLite3 rule is here. See? Awesome. So this should all be rigged up to let us do something like, let's try to see if we can find some text that we can change. Help messages. Perfect. Help list all the test controls, string compare, help. Yeah, I want to look for literally this. Enter help. There we go. Inside this function, it's quite long. It's a very long function. Going, 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 higher, higher, higher. Where is the function start? Okay. Have I missed it? Am I still going? Nope. Oh, wait, we're editing the wrong thing. We need to edit this one. Yep, okay. Yep. And let's just really crank this up and try to find the start of this. Now, actually, what we can do is, this seems to be right near the end. Do meta command. If an input line begins with dot, then invoke this routine to process that line. This is a lot. So this starts on line 6,907 and it ends on line 9,603. That's about roughly 2,500 lines. It's 2.5. Cool. So let's see if it's built yet. Let's wait. This is a bit slow. So one of the things we're going to want to do in the future is find faster ways to build these. Okay. Oh, we're looking in the wrong place. This is what we want. Awesome. Now it might be sort of helpful for us to time how long this top level pass takes, and if there's ways that we can hone that in when we start hacking on specific modules. But this is a really awesome start because it means if this works, which it should, now we can begin kind of exploring stuff. So that's still not working, right? Now we can kind of start debugging this by saying shell.c, which is a generated one. And this is producing the right thing. I don't know if the SQLite 3 command is getting removed on every invocation. It might be seeing it there and saying, I don't have to do anything. I shouldn't replace it. Depends on what the makefile is explicitly doing. But let's have a look. You'll see that, yeah, there are these commands. If student is interactive, this is what we get. That's what that. No, still getting shit here. Yeah, boom. It was not replacing the binary. It was keeping the same one there. So in the future, if we want to do stuff to some output binary, we might have to explicitly force the thing of it. And in fact, what probably should be happening is like make clean and then make. It just depends on how vicious this clean rule is. So it removes a whole bunch of the generated stuff. Does it remove shell C? yeah, remove shell C, etc. So what we can instead do is this, and make -s requires commands to be a single argument. Okay. Instead of having this, there's two ways that we can do this without -c. The first way is, and let's just remove -c for starters, regardless of it finishing successfully or not, we say done. And like add a plus or something. That's one way. The other way that we could rig this up is that it, you know, I'm going to do both of these in tandem actually. You can tell enter to clear the screen. And so now you're going to see all the steps it's going to take. It's going to run this once. And yeah, we kind of have something of a start, which is, I'm just going to keep jumping around here to try to find the beginning of this function. Save that. I don't know what is going on here. I know what's going on. I know what I've done wrong. Because we've said -c, the way that this is getting parsed is not quite what you expect. So I have to change a couple of things out. Yeah. So we do actually need this to be a shell invoked command because it's running multiple things. Right. So we're going to say -c plus -s. We don't need that anymore. And we can run this. Awesome. That's all we needed. Let's keep going up a bit. Before we finish, the last thing I'll kind of do is we'll take a quick look at this. I'm hoping that this is fundamentally our start. Oof. There is a function called main init. So we are on the right path. Once we have some sense of where there is an entry point, we can do a sort of top-down breadth first or depth first or whatever kind of search that we want to perform, usually out of curiosity of like where we want to explore and what we want to go change. But hopefully I've demonstrated a way to get a feedback loop going, even if it's a bit slow for now. A way to like start poking and making changes. One thing that I will do in the future is we'll actually keep, you know, some file open to just like ask questions, right? Yep. And it's like, why is foo bar so long, right? What is a SQLite 3 prepare statement or something? And normally I would do this with a journal, but the idea is that, so that you guys can see some of my thought processes and stuff, we'll do that with like to-do lists, and we'll make really quick and lightweight to-do lists and scrap them out so that we can try stuff out. We'll kind of keep a log of questions about like what do we want to explore and what's really important, and that will help us kind of prioritize and focus on essential stuff rather than getting bogged down on really, really tiny details. And we'll do some top-down stuff, but it also might help to kind of say, look, you know, maybe there's a couple of functions or things that we just want to sort of know how they work, but they may not be tied into the core sort of path that we're exploring. We did see this main init one, which is a good sign, and now in the future we can kind of keep track of this, where we were. So there is this main init function that's doing some data munging. It runs memset on some data. It sets something called normal mode, auto explain. It copies over some stuff. Data, I'm assuming, is a configuration thing, so this is what it's called shell state. So rg shell state. I only want to know the files. So tag shell.c source shell.c.in, the TCL source shell.c.in, and the tsource shell.c. Okay. Shell.c here was the output. This is the distinct TCL stuff that we're not directly dealing with. And tags, I'm thinking, is a fossil thing. If I go, oh no, tags is my thing, sorry. I made some C tags at the beginning. My bad. That was so I could jump around and do stuff like this. Yeah. So this is setting up some shell state and running some configuration commands. So it asks shell SQLite config. So I think it's setting these. SQLite config URI to 1, SQLite config log, shell log and data, SQLite config multi-thread, because it's not assigning to anything. It's just taking, yeah, it's probably poking some static state. And then it says size of main prompt SQLite, and then there's a continue prompt, which is what this looks like. So if we wanted to change how the continuation prompt looked like, right, what we said, then what we can do is you can say that. I've kicked off a new build. When that is done, we will be able to see that in action. It is quite slow, isn't it? We're going to have to sort of explore ways to kind of cut that down. There may be, there may not be. This is still better than like manually building and, you know, kind of checking and stuff. Sometimes the simplest thing to do is actually make a test. Tests are really just a way to think about tests is like synthetic traffic on some tool or service or whatever. And so you're providing the synthetic traffic, like you're doing this sort of simulated evaluation of the stuff, of the program. And by having this sort of simulated evaluation of the program, you've effectively given a really fast way to just say, I just want you to run specifically this tidbit, right? What's really important is to get out of the habit of like running lots of tedious tasks and tedious things to get little results, right? If you just want to see one thing, just zoom in on that one thing. If it's taking you forever to reset an environment, figure out ways or script ways or whatever, get creative about how to speed up that process. Okay. Select star from no such table foo. What was the name of our thing? Databases. Tables. Interesting. Create table. Ah, maybe it nuked what was there. No, that's interesting. Create table foo. ID int primary key. Name string not null. Insert into foo. Name values. Select star from foo. Well, beautiful. So gorgeous. Okay. Get out of that. For example, with the test-based thing, maybe we could just quickly write a test if there's a test thing related to this shell stuff. It doesn't look like there is. There's test OS S shell. This test interface for the OSS fuzz.c module. So this is a way of them fuzzing the shell, but I don't think they have anything like golden tests or anything. Golden Lee? Some interesting thing here with some text about Genesis. Right? genesis.tcl. Some mention of the golden ratio in this hash module. Yeah, weird. Okay, so let's also look for a snapshot. Snapshot committed. LSM test, permutation test, snapshot3.test. Wall block, snapshot fault test. So snapshot here could mean the type of test, where you're taking a snapshot of, say, output or whatever. It can also mean the internal database thing of like having a snapshot for, say, there is an isolation level called snapshot isolation. What is it called? Snapshot, yep, isolation. And snapshot isolation is a bit like, if you are familiar with software transactional memory, if you are familiar with journal logs, etc. Software transactional memory is a type of concurrency that is optimistic concurrency. The idea behind software transactional memory is this idea that instead of a pessimistic concurrency model where you say, everybody move out of the way, I'm going to buy my groceries now, right? And you push a bunch of people out of the way, and then you take the lock of the grocery thing, and nobody else can get groceries until you finished. The optimistic concurrency model is sort of like this bunch of people pushing out of your way and like also trying to get their stuff in there. Except what happens is at the very start of the action or the critical section or whatever, a view of the world is taken, some snapshot or some, recording of state. And while you're doing your stuff and you're trying to kind of get this job done, by the very end, when you're ready to commit, you check that state of the world. And if the state of the world hasn't changed, then you can be sure that you're safe to commit. Because even if somebody came along and they changed a value, it was to the same value it was before. Which means that now work that's kind of idempotent or whatever can go along. It doesn't have to be blocked, which is nice for some access patterns. And the other thing that it means, though, is if the view of the world has changed, say a single variable or some single thing, it is not quite what it was at the beginning. If the snapshots before and after differ, then you have to throw everything out and try again. And you redo and you redo, and you might have a limited number of times that you retry, and you might retry indefinitely, depending upon what the particular critical section is and what action is trying to be performed. The thing about a critical section and the thing about STM and optimistic concurrency and stuff is that if you have a really, really, really long function, or let's just call it an action that has to happen. If it's going to take a really long time, there is a higher and higher probability somebody else will come along and change the view of the world out from you. Okay, if multiple people are touching something. Okay, if it's really short, which is the ideal thing, then it's much less likely that people will come and change things while you're trying to do stuff, and you'll be able to commit things. And also, people are welcome to change other unassociated parts of the system that might, be disjoint from what you're doing. So it kind of opens up a little bit more throughput potentially, but again, everything is a trade-off. There's always the possibility that you might wind up in a situation where this is not actually beneficial. Maybe it's not very extensible because now you have to keep all of these transactions really tiny. Snapshot isolation is an isolation layer for databases that is similar to software transactional memory. I'm trying to see if there's any mention of it. Now, people can probably gut me for saying that it's similar to software transactional memory. Pedantism is a good thing in our field, but it can also be a bad thing. Yeah, cool. That's a really good intro, I think. of what we've sort of gone through. And this main init now has given us a place where were we? We were in some main function. Yeah, wmain, awesome. If the SQLite shell is UTF-8, we have our main function. And this is how we discovered this file, right? We went and we said, where is main? And I'm just gonna show files. And you'll see we kind of had a look around. And somewhere in here, I'm gonna cheat. My bad. Somewhere in here was shell.c.in and shell.c, etc. Here is our entry point. We will explore the main file and what it does to get going, what kind of, interactive loop it sets itself into, and what it will allow, right? And that will actually give some idea from a shell perspective of how SQLite might run. But SQLite might also run as a service that exposes itself via, many databases, for example, like MariaDB, MySQLDB, Postgres, etc. They act as services that communicate over a port, right? So there's some kind of socket connection, TCP generally, and then they'll communicate over that. It might be cool one day to dig into, just as like a tangential thing, how Postgres or MySQL or whatever do that specific communication. That might be a bit educational for people. But yeah, I hope that this was fun, and I really look forward to the next video.